Yep. Good evening, everyone. So, so let's start off. Hope everyone went through the fluid mechanics notes. You should do that after every class. Every class gets over at least on the same day or the next day should take out the notes and resolve all the questions. If you don't do that, you won't remember stuff. Where are the rest? Let's start off with a problem. Last time, if you see right, we are doing a combination of thermodynamics and fluid mechanics questions. Let's say we have a vessel filled with water, density rho, base area is A, the height is H. Gamma is the quotient of volume expansion of liquid. Others comes on. Alpha is the quotient of linear expansion of container. Find the change in pressure at the bottom of the vessel when the temperature increases by delta T. So when you increase the temperature, right, the liquid will expand, the container will expand, many things will happen. Find the change in pressure at the bottom. When temperature changes by delta T. This is a question based on thermal expansion and fluid mechanics. Try, it's a good one. This will be a proper mains level question. You're having your dinner, you can keep your cam off. You just message me you're having dinner. You can keep your cam off 10-15 minutes. I understand. This is the first question. Problem is you keep the cam on for 2 hours and you're eating food. That's not acceptable. How do we do this? So we have a container with base area A. The liquid is filled up to height H and density rho. So when you heat the liquid in the container will expand, liquid also will expand. Multiple things happen there. Find the change in pressure at the bottom of the vessel when the temperature changes by delta T. Any ideas? Yeah, everyone, let's see. Now here in this problem, right, the first thing, it looks kind of overwhelming, or a liquid be expand or a container is expanding. Let's keep it simple and you will see what is the pressure here. If you just see in terms of this way, the pressure at the bottom is nothing but what is the total weight of this container, mg? So pressure at the bottom, so upper say this will be P naught into area. So from the bottom, it will be pressure into area. So pressure at the bottom is simply PA is equal to the weight mg plus P naught into area. P is equal to mg by area plus P naught. Everyone agrees? Keep it in terms of mass, okay? Now, if you expand the liquid, will the mass change? Mass remains same even if temperature changes. So if you look at the new free body diagram, what will change in this question? The liquid height has changed, definitely. Liquid density has changed, but the mass has not changed. So mass will still remain same. And this will become P naught into the new area, which is 1 plus 2 alpha delta T. Remember thermal expansion? The coefficient of aerial expansion is 2 alpha. The area will increase by this thing. And the bottom of the base, P into area into 1 plus 2 alpha delta T. So the new pressure P dash will be P naught plus mg by A into 1 plus 2 alpha delta T. But this is what you have to do. You need not worry about the expansion of liquid and everything, because no matter how much the liquid expands, the dense mass won't change. So the change in pressure P dash minus P will be mg by area 1 by 1 plus 2 alpha delta T minus 1. Check. That's your answer. You're getting this? So if you keep the whole question in terms of mass ka perspective, you need not worry. Now, some people will have a doubt. Sir, what is happening? The density is changing now. Let's see what happens to here. Mass will be the new density into new volume. What is the new density? Rho by 1 plus gamma delta T. What is the new volume? 1 plus gamma delta T. This will cancel. This will be rho into V. This is nothing but the old mass. Are you getting the guys? So whenever you expand, your density will decrease, volume will increase, the product will remain same. So the mass will not get affected. I hope that was clear. Please have a look at the steps. Clear? Abhiksha, Ammu, Kamson. Nishita, understood now? Siddhi, got this? Harsh, Vrinda, Kavya, clear? Radhi, Reina, Dania, clear? Go ahead, next one. Turn in the page. Yesterday VIT का results came up, Vellore Institute of Technology. ठीक है, इतना super university नहीं है, but VIT का computer science is better than many private colleges in Mumbai. So in that, if you see, so students were asking, sir, I got this rank, what to do and all. There's a student who got 2000 rank, there's a guy who got 25,000 rank. So the difference is everyone will get an admission, but there are different categories. Category 1, category 2, 3, 4, 5. Then he was asking, sir, kya hota hai category? Category 1 fees is 2 lakhs per year. Category 2, 3 lakhs, 4 lakhs, 4.5 lakhs, and 5 lakhs. It's a private college, right? End of the day, they're just trying to sell you more seats. So that's the difference. So yeah, but if you could join in a college like NIT or something, I think the fees is only 1.2 and the degree is much more valuable. BITS is much better in that sense, BITS mein, there is this BHONSCA program where they'll give you 2 degrees within 5 years. You can do chemical and computers, electrical and computers like that. If someone is really keen on computer science, you need to put some more work. But technically speaking, right, most of the things it doesn't matter. Nowadays, everyone knows after the 4th year, you can go into any field. Let's say we have a container rotating with omega, neglect gravity. So this is your axis. This is x is equal to 0, and this is some x is equal to L. The liquid density is rho. Find the pressure at a distance x. It's a rotating cylinder. Find pressure at distance x from axis. Do you remember we have done something similar like this before? You know where? Anyone remembers that?
C1.
Where?
C1.
Nah, re.
Circular motion.
Circular motion. Do you remember or just guessing?
Remember, sir.
Yeah, the question 15 one. A rod is rotating with omega. Find the tension as function of x from the axis.
Yes, sir. We took t and then t plus dt.
We take t plus dt and then we solved it. How do you do this? Try. I'll give you a minute. How do you do this? See, at a distance x, take a thin strip. So these are all the ideas in this problem basically. So if you look at the pressure here, this will be P into area. This will be P into dP into area. And this will be dm omega square x centrifugal force. So the dP into area, the pressure difference is balancing dm omega square x. And this will be density into area into dx is omega square x. A will cancel. We get this is rho omega square x dx. Integrate. This will go from 0 to x. This will go from p axis minus p. So the pressure difference P minus P axis is equal to rho omega square x square by 2. Quite an important result. You need to remember this. So the difference in pressure at a distance x from the axis is this. Put it up. Let's see how they'll frame a question on this. If they ask you just this result, it will be like a CT level question or a bits one. Clear? Next one. So let's see how they'll frame a question on this. I'll just call this 11A. We have a U-shaped tube here. You're rotating about this axis at a distance of L by 4, at a distance of 3L by 4. Because of this, what will happen? The liquid will be like this. So this side the height will be H2 and this side the height will be H1. Find H2 minus H1. If you had rotated exactly in the center, they would have been equal. But you're rotating more to the left, so heights will be different. Any answers? See. Let's call this point A. Let's call this point B, and this is your axis. Now from the formula, what is PA minus P axis? Rho omega square x square by 2. No? So here x is L by 4 whole square by 2. Similarly, PB, so this formula is always valid from the axis. Huh? You can't do between A and B directly. Rho omega square by 2, 3L by 4 whole square. So if I subtract them, I get PB minus PA will be rho omega square by 2. That will be 9L square by 16 minus L square by 16. That will get 8L square by 16. The rho omega L square by 4. And what is PB? PB is P naught plus rho GH2. What is PA? P naught plus rho GH1. So we get H2 minus H1. Rho will cancel. Omega square L square by 4G. Check. Harsh, you got it right. Is this clear, everyone? So if you don't know the previous result, you can't solve this question.
Sir, but physically, while rotating, why would there be a pressure difference? Means, is there any force more on that side?
So you think there's no force acting on this? तो यहाँ पे प्रेशर डिफरेंस क्यों आ रहा था? शौर्य, यहाँ पे प्रेशर डिफरेंस क्यों आ रहा था?
अब तो सेंट्रीफ्यूगल फोर्स था.
देन यहाँ पे क्या था? यहाँ पे नहीं होगा सेंट्रीफ्यूगल फोर्स अकॉर्डिंग टू.
सर बट वहां पे तो पाइप जो था वो हॉरिजॉन्टल था, यहाँ पे तो वर्टिकल है ना. उस
सो मतलब ये हॉरिजॉन्टल नहीं है अकॉर्डिंग टू यू.
हाँ यहाँ पे होगा पर ऊपर वाले.
व्हाट यू टॉकिंग रे शौर्य? यहाँ पे प्रेशर क्यों बढ़ेगा? बिकॉज ऑफ दिस सेंट्रीफ्यूगल फोर्स ना. इससे क्यों बात कर रहे हो तुम?
अच्छा ओके.
द प्रेशर हियर इंक्रीज बिकॉज ऑफ दिस हॉरिजॉन्टल पाइप. बिकॉज वो प्रेशर ज्यादा है इसीलिए द वाटर वेंट अप.
ओके.
राइट?
यस.
All clear with this? Next one. This is an important result. Huh? Next one. This is an important concept. This we will see in at least 5 to 6 chapters. We'll encounter this projected area. We will see this thing in fluid mechanics, surface tension, electrostatics, magnetic force, EMI. One more place we'll see. We'll see somewhere else. I don't remember right now. Modern physics comes in different chapters. So what is this concept exactly? See, suppose if you take any random amoeba shape like this, completely a closed figure, closed, massless, body. Now tell me, if you have a pressure P naught here, how will the pressure act on this? The pressure will act on every point. So on this thing, right, the net force should be 0, isn't it? What happens if the net force is not 0? If net force is not 0, and if you keep it in the room, what will happen? It will just fly, right? Think about it. Agar usme net force, if the net force is not 0, it will start moving around everywhere. Are you getting it? It will just gain energy out of nowhere, right? Who is giving it energy then? If there's no force acting, meaning if there's only pressure acting, and if it's a massless container, it will just not going everywhere. The meaning, if you take this shape here, this random amoeba thing, and if you take this niche ka disc or whatever shape it is, so the force acting on this curve and the force acting on the disc should cancel out. So force acting on the curve and the force acting on this area here, or let's call it flat surface, should be equal. So what we can call is this, the projected area simply defined as a flat area. Now see, this will make your life much easier in calculations, which makes an open surface into a closed surface. Meaning the whole figure should be closed. That area is called projected area. Example. Suppose if you take a hemisphere like this, if the pressure is acting on this surface, P naught, what is the projected area here? The disk, no? This is the projected area. So the force acting on the curved area, the hemisphere, is given by P naught into pi r square. There is no need to integrate, no need to do anything. Directly you can get the answers. Suppose if I take something like this, a cone of height h, and radius r. What is the projected area of this? Let's say pressure is acting like this. Now, what is the projected area? Again, this thing, no? Basically getting it a flat area. When you keep it, it should become a closed figure. So this force on this curved part will be again P naught into pi r square. Suppose if you take a half cylinder like this, how do I draw this? If you take an half cylinder like this, let's say length L, and the radius is r, and if the pressure is acting like this, what is the projected area?
LR, P naught.
So here the projected area will be that, this thing, no, rectangle at the bottom, right? Where this will be 2r and this will be L, isn't it? The projected area will be P naught into 2r into L. Is this clear, everyone? So you can take any random surface and the answer will remain same. So if you take a disc here and you take some kind of amoeba shape here, it doesn't matter. The projected area is still this. The force on the curve will be P naught into pi r square, if this radius is r. But the only drawback or the only condition for this thing is valid only if the pressure is constant. If the pressure is changing, you can't use this formula. That is the limitation. Please have a look at this example.
So could
The
you
pressure has to be constant.
please-
All right.
Okay, sir. Done.
Clear? Now, let me ask a question on this. What if I take half cone? If I take an half cone, height h and radius r. The pressure is acting like this. Now, can you tell me the force on the half cone? Find force on left half of the cone.
R into H.
Left half of the curved surface of the cone. How do you do this? Think, everyone, I'll give you a minute. Theory part again. This one. That's not the complete answer. Clear, na, Abhiksha? Confused? Any doubts? No. How do you do this thing, everyone? Again, go back to the definition. What is the definition? A flat area which will make an open surface into a closed surface. Tabi yahan pe, in this case, if you see, there are actually two flat areas. You need one area like this to close the bottom. You need one area like this to close the right side. Isn't this? then it will become pura closed, na? So this guy is actually equal to one half disk and one triangle. So on this, the force will be pressure P naught into pi r square by 2 half disk minus j cap. On this, the force will be pressure P naught into area half into base into height. P naught RH I cap. So the force on that curved surface will be P naught RH I cap minus P naught pi r square by 2 j cap. So projected area need not be a single area. You can actually create two flat areas. Got it? So look at the definition. A flat areas which will make an open one into a closed curve. So if you put one disk at the bottom and one triangle on the right side, it will become closed. Clear? So you can play like this. So this is how they'll extend it. Someone is confused. Please ask.
Sir, but the cylinder that you
हाँ, Danya.
showed, the cylinder that you showed, half cylinder,
हाँ.
was it closed like from the bottom?
Actually क्या होगा ना? नहीं, bottom से close नहीं है ना. I'm just
Then
asking the
it's-
force on. I'm just asking the force on the curved surface.
Okay.
If it is closed now, if I ask you total force, it is 0. I just want to find the force on that curved surface. Got it? Mm.
Sir, but
All
here,
these are
why don't we-
all these are open surfaces only. All these examples are open surfaces. So the color which I shaded, right? So in this case, the projected area will be this, na? That will be the projected area. Got it?
What about the half circles on the bottom and top?
This side way you're saying,
Yeah.
वो cancel हो जाएगा ना? This half disk and this half disk on this side, this will cancel out horizontally.
Oh, okay.
They won't matter. Then, any doubts on this?
So
How is it minus j cap? देखो ना, Amu, pressure is like this, right? So इसका vertical component and horizontal component, na? It's pushing down, isn't it? It's pushing down and it is pushing right. Huh, Reena, you said something? No, someone said something. Any doubts? All got the idea of projected area? Remember this thing? How did you say it is minus j cap? Because see na, it is pushing this way na, so its vertical component is down, horizontal component is right. Na? That's a minus j cap. Remember this projected area concept. We will again encounter this next time in surface tension. Pretty useful concept, saves a lot of time. Proper main level questions you can get. There's no need to do integration, nothing. Now, based on this, there is even a better result, a very good result than this. So you can actually put it down. So if you have a liquid, and let's say you immersed some, again, random plate, anything. So the question of this thing, so if you have center of mass here, the force on this plate, this is a force on a surface immersed in a liquid, is given by pressure at center of mass. We will not do the proof for this, but the area. So you can find the pressure of this thing. Let's say if this is H. So here's the pressure at the center of mass will be P naught plus rho g H. Example. Let's say if you take an half disk, now if I ask you force on one surface, okay, one face, force on one face of the half disk. Are you getting it? See, when you put the half disk in, you're getting how it is? I'm taking a disk and immersing like this. If you can see my video screen, I'm just taking the disk and immersing in the thing like this. I'm asking you find the force on the front face. Got it? Actually, liquid will push from both the sides. Now, वो तो cancel हो जाएगा. But if I want only on one space, this is given by pressure at center of mass into area. Where is the center of mass of half disk? Where is the center of mass of half disk? This is the center of mass. 4r by 3 pi. 2r by pi half ring here. So this will be r minus 4r by 3 pi. So the formula will be P naught plus rho g r minus 4r by 3 pi into pi r square by 2. Pretty good result, huh? Saves you a lot of time. You just take the center mass of that thing and finish it off. You never expected na center mass aayega yahan pe. First time when I did this thing 3-4 years back, even I didn't expect. Once I got the result, I was shocked. I just gave it for fun in the class half this, and I found it is an actually a center mass result. And I'll tell you why it works. What is center mass formula if you remember? X center of mass is integral dm into x by integral dm. No? Can you see x center of mass is proportional to x power 1, right? What is the pressure equal to? Rho g x. Na? If the functions are linear, you can use center of mass concept. This is quite a useful concept. We will see this again in electrostatics, dipole moment. We will see it multiple places. The center of mass thing keeps popping up. So you have to mug up center of mass results. If you just forget it, you will mess up at multiple places. Are you clear with this thing? Let me give you one more example. Suppose if you immerse a triangular sheet, where is the center of mass for triangular sheet? Anyone remembers? I'll show.
Centroid,
Centroid, na? Where is the centroid height?
2h by 2 by
2h by
3h.
3, na? Divides in the ratio 2h by 3. So the force on a triangular face will be P naught plus rho g into 2h by 3 into half into the base, whatever is that, into height. That will be the force. If I take one more example, if I just take a square ka sheet,
So
where is the center mass of square sheet?
Intersection of diagonal.
Center of center, na? So this will be like L by 2, na? So P naught plus rho g L by 2 into area L square. That's the force on a square sheet. You're getting? You can just take center mass and finish it off. Someone is saying something.
Sir, the pressure is means the object is kept horizontal in the liquid.
It is immersed in the liquid, right? Basically, these are sheets. A sheet is immersed in a fluid. It is not a solid object. Huh? This formula is valid for sheets. Have a look at these examples.
Liquid.
So the formula gives the force acting on every surface, right?
Yeah. You can take any type of. That's why I say I gave you some random surface, but you need to find the center mass of that random surface. If you can know the center mass of that random surface, the result will work. But generally, they'll give you something like, which you know center mass, or else you can't solve it anyways. All sure with examples? Only condition is valid only if the pressure varies linearly or it's constant. And only works for force, huh? H was the distance from the top of the liquid, yes. Is this clear, everyone? Now, this thing, if you combine both of this thing, the projected area and this center of mass, you can get even a better result. Turn the page. Any doubts on this thing? Now look at this example. This is even better. Let's say you have a totally random curve like this. You're getting how it is? Imagine, you have a cake in the house. Your brother just puts the hand and removes a slice. Able to visualize? You get a weird color piece, right? The shape will be totally random. So here the pressure will be acting on this surfaces here. I'm unable to draw better than this. Getting it? The pressure will be acting like this, and there is a liquid everywhere. The pressure is not constant here. Okay, so I want to find the pressure on the curved surface, force on the curved surface. The horizontal force, okay? We can find only the horizontal component here. The horizontal component of force on the curved surface. And I'll show you how they'll frame a question on this. Curved surface is given by pressure at center of mass of the projected area. So first to take a projection of an area, uska center of mass nikalo into projected area. Meaning for this guy, what will be the projected area? This, na? Isn't that be the projected area for that curve? This will be the projected area. So you just take that projected area here, find its center of mass, find the pressure at that point there. So just to give an example, let's say if this guy was some H and this guy was some L. So this was H and this was L. So pressure at this point will be H by 2. So pressure is P naught plus rho G into H by 2 into the area will be L into H. That's your answer. So you can combine the projected area and the center of mass concept together and you'll get an answer like this. Can't it be any phase? Mu, what do you mean by that?
The projected area can't it be any phase?
No, projected area, see na. You're saying this one, you're saying.
Anyone can't it?
No, if you take this, iska vertical component aayega na. We can only find horizontal components. Vertical components you can't find.
What about the phase behind?
Where is the phase behind?
मतलब पीछे वाला से.
Yeah. That is water, right? There's nothing there.
अच्छा.
मतलब see side view na, agar if you see right, it looks like this. ऐसा दिखेगा ना?
Yes, sir.
Got it? There's nothing here. That's just water, no? Water is pushing it.
Okay, sir.
That will generate a horizontal force. That will be equal to the force on this guy. Are you getting this, everyone? So if I give you even a random curved surface, you can drop a projection of that and projection ka center of mass, and then you can find the pressure into area. Quite a useful result. So let me show you how they'll ask question in advance based on this.
Sir, can you show the previous form? Sir, previous. Yes, sir.
Next thing. Got it? Let's see how they frame a question on this. This projected area thing, right? Make sure to go through that. It's not difficult, but you should have seen this once. So we got a cylinder here. On the left-hand side, it is filled with liquid. Of density 2 rho, and the height is r. On the right-hand side, you filled with the liquid of density 3 rho, and the height is h. And the cylinder is at rest. Mean both the liquids are exerting equal force. The cylinder is in equilibrium. Find h. Cylinder का radius is r. Find the torque due to each liquid about the center of the sphere. How do you do that? How do we do this? यहाँ पे problem क्या था actually? Do you observe? The pressure is acting on this curve, and so what should you do here? So is this curve का projection will be this now, and this red liquid का projection will be this now. You have to find the force on this red part, and you have to find the force on this green part. It's a cylinder, isn't it? If you cut the cylinder vertically, क्या आएगा? You get a rectangle, if you cut it like this. So you actually try to find the force on that rectangular sheets. The force is equal होना चाहिए. Did you get the diagram? What I'm saying? Try. I'll give you a minute more, and then I'll show you. So for the green liquid, if you see, when I take the projection for half of it, this is the projection, right, for the green one. Let the length be L, let the height be R. So if you take the center of mass, that will be here. So the force due to the green liquid will be two rho G R by 2. Center of mass is at a depth of R by 2 people. It will be at the center. Area will be L into R. The same way for this guy. It's like this. Not a complete thing. So the red liquid is like this. This is the projected area. Center of mass is here. This height is H and this is L. So this force will be 3 rho G, height is H by 2 into L into H. These two should be equal. 2 rho G R square L by 2. 3 rho G L H square by 2. Rho G2 L L. H is equal to 2 by 3 per root into R. Check it out. That's your answer. Easy? Understood the process? And I know it is not easy, but you got the concept, right? Normally, you couldn't have solved this problem. Integration was a big mess. You just need to take the projection, the flat area आएगा, उसका center of mass and finish it off. All clear with this? Which part, Ramu?
We can show it from the start.
Wait, at the end of the class, we can stay back.
Okay.
What happened? You didn't focus, suddenly felt sleepy. Idea was simple, na? देखो ना, you just need to take this curve is there. इसका projection will be this, na? Now for a cylinder, what will be the projection? If you take a cylinder like this, and if you cut in the center, क्या आएगा? Rectangle आएगा. Na? So here, what will you get? You get an half rectangle, na? So that will be the projection right here.
Yes, sir.
So uska center, what will be there? So this is the left thing. So this is the projection, na, for the green liquid. The green liquid is still here, isn't it?
Yes, sir.
So uska center of mass is where? R by 2. So pressure into center area. What is the pressure? Rho G H
Understood now.
into area. On the right hand side, be same karna padega, na? But this time height of the rectangle will be H only.
Okay.
Sure. Pakka, na? You're just saying so that you
Yeah,
will not.
the end of it.
Clear, everyone. Next one. Got it? So this is a good one. There's still one more question I asked to find the torque. How will you do that? That's an interesting one. See, how does the pressure act? The pressure will always act along the normal.
So what will be 0?
So the force will be always what? Passing through the center, no? It doesn't matter. No matter how much area you cover, you'll always pass through the center. If the force is always passing through the center, what is the torque? 0. Since force due to pressure always passes through the center, torque is 0. is along normal, that is center, torque about O is 0. That would be a straightforward easy question. Right, Raina? It will be 0. All clear with this? Clear, na, Brinda? Aviksha, cam on. Ritam, Trisha, cams on, everyone. Anamay, got this. Raddi? Geet? Perfect. Next one. Another standard question based on something similar. Okay. Someone is like, sir, there's an insect in my room. I'll switch on the fan. Happens. If there's an insect in the room, you are going to fight a war with it. So this is still fine. If you see my medical batch in the morning, a cockroach comes in, these people start jumping everywhere. I said, Brady, you guys are going to dissect it, when you go for MBBS. You can't get scared of it. So, people keep jumping, shouting, girls get scared. So there is one girl who sits in the second bench or something. She just took the book and just smashed the cockroach. Like, she got so pissed off and said, now it is dead. Everyone keep quiet. Karke. So from that downwards, we call her the killer. Any insect comes, everyone looks at her. Kill it. Karke. So, okay, happens. So we got a square plate. And it is completely, filled with liquid on one side. So basically, the square plate is blocking it. Side A. And density rho. So someone is applying a force F here to keep the plate from rotating and falling. The question is, find F external and X. So how much force should you apply and where should you apply so that the plate remains in equilibrium? You don't want the plate to rotate. You don't want the plate to go left and right. Now I'll tell you what exactly happens. Okay, if you take the plate, right, the side view, can you tell me where will the force be more? If you see, as you go down, the pressure will become more and more, right? There is more pressure at the bottom. So there's a tendency for the plate to become like this. So you have to apply a force little below the center of mass in order to keep it balanced. And because of this reason, how dams are built. If you ever seen a dam ka walls, they're built like this. You make the base very pretty thick. If you make a dam ka wall like this, it will just get pushed away. So this is the walls of a dam. And when is a dam more stable? When it is fully filled. As the water is getting filled more and more, the dam actually becomes more and more stable. Reason, look at this, how it works. If the dam ka walls are filled up with water here, the pressure is more, no? They'll push the dam like this downward. Because of this, the normal reaction will increase. Because of this, the friction will increase. So if the dam is full, it actually generates more pressure in the downward direction that pushes the dam towards the ground. It makes it more stabilized. So whenever they build a dam, this is how it is constructed, the curvy shape. Nothing happens. If it is half filled, it will be there, but I'm saying it will be more stable if it is fully filled. See, when there's a summer or something, dams won't be always full, right? Generally, people think, what are a dam full ho gaya, it might break. Right? So the thing is, when the dams are full, they're actually more stable. Dams generally don't break that easily unless there's a big structural failure. The reason why, movies where they show a dam break, okay, pura pani aa jata and all, like, kind of nonsense. When the dam is breaking now, you will know at least 3, 4, 6 months before only. It is not like suddenly one day night the dam will break and water will go. That happens because hero will have nothing to do, right? imagine a story where dam is having a leak. The hero comes to know 6 months before the dam breaks. The government will take some action, repair the dam or evacuate the villages. One fine day, the dam will break, all the water will flow into the ocean, no one died. There is no issues, nothing. Movie ends like that. Pretty boring. Movie ऐसा होना चाहिए. One day everyone is sleeping, dam will break, it will flood the city, 20-30 villages will die. Then it is later on found out the villain actually blasted the dam, or villain has taken bribes and stolen the dam. Then hero will come and fight. Then bloody it feels like a movie. This is a movie. Karka. Problem is that in movies we make it so dramatic, right? So it gets boring. Real life ka villains and real life ka heroes are actually boring. Seriously, real life ka heroes and real life villains both are boring. It takes time. No one has the patience. So, anyways, how to solve this? You should, someone is interested, right? You can see the construction of Hoover Dam. They make the dam, meaning the dam actually is built like this, like an arrow. This thing in the Boca shape. The reason when this is pushing this way, the pressure, right? This actually gets strengthened. It's a pretty interesting structure. Hoover Dam is almost like what 120, 130 meters tall. It is built on the Colorado River. India also we have pretty big dams. Nagarjuna Sagar, that's a pretty good one. How do you do this? Think for a minute. Find the F external. That is easy, right? You can just use centromers and finish it off. Find F external. I'll just be back in a minute. You guys still didn't get F external. That was easy, right? You just took the pressure at the centromers into area, no? Right? But let me show you another way, because torque we won't be able to do that way. So if I take the sheet here, at a distance x, take a thin strip dx. So on this thin strip, the force will be rho gx. We are not taking P naught because P naught is acting on both the sides. It will cancel out. Left and right, both the sides, the atmosphere is there, so it cancels out. So this will be rho gx into area. So the small force on each strip will be the pressure rho gx. Area will be, this is A na side, so A into dx. So the total force F net will be integral 0 to a rho g a x dx, which is rho g a cube by 2. Check if you use center of mass, you get the same answer. Center of mass pressure is rho g a by 2 into area is a square. Did you see single step? You'll get the answer. But you need to do this because, so what will be the torque then? So torque on each strip will be x into force on each strip. So this will be rho g a x square dx. If you see, this is a square function. This is not linear function. You can't use center of mass. Center of mass concept you can use only for center of mass. Therefore, we cannot use center of mass. So torque net will be integrate this stuff. Rho g a integral x square dx from 0 to a rho g a power 4 by 4. So this torque net should be equal to F net into h. Let's call this thing h. And what is F net?
A power 4 by 3, right?
3. So the torque net will be F external into h is equal to rho g a power 4 by 3. F external is rho g a cube by 2 into h is rho g a power 4 by 3. H is equal to 2a by 3. You can mug up the result. Exam like mains of it's not direct result. You should apply a force of rho g a cube by 2 at a height of 2a by 3 from the top. Check it out. It's a pretty good result. Standard equation.
Sir, sir, the formula of horizontal component of force on that formula we only use for all surfaces.
Only for force. Right, Arushi. For finding torque, we can't use center of mass. Only for forces, we can use center of mass. So if they ask you to find the torque, rotational equilibrium, Gaya, you have to integrate. There is no way out. Oh, pura, whatever I taught you, that pressure, center of mass, all that will not work. That is a drawback of that thing. But it saves you quite a lot of time if the questions are surface is quite weird. But then again, see, if you're getting something very fast, there is always a compromise. Only for curved, matlab kya hota hai? What is curved?
Sir,
Curved.
yes.
Yeah. It's like, you know, that thing na, in life, right? See, you're always limited by time. There's always a compromise. So when we discuss, normally we used to have a discussion with friends. In life, there are 3 things, okay? Fame, money, and time. Choose 2. You can have 2 in life. Some people don't even have 1, but you can have 2 in life comfortably. If you want fame and money, forget about time in your life. If you want money and time, forget about fame in life. Think about it. If you're an actor, you have a lot of fame, you have a lot of money, but you won't have time for yourself. And if you decide like, nahi, mujhe time chahiye, that means you'll stop making movies, right? So maybe you'll have money and time, but people will forget about you. So you are famous and you have time. Maybe you're a super famous scientist. You have to, you might have time. You won't have money with you. Maybe you're not that successful. Kya bata? Maybe rarely some people can get all 3. Maybe rarely. Look at Elon Musk. Super famous, super money, no time. So most people fall into that category. Again, see, whenever I say it's generalized, exceptions are always there. So in life, you choose to. So this is what we do, na? Kal exam hai, padhai nahi karna hai. So one day before we sit and do what? We talk about life. We think about why this life is like this. IIT mein yahi hota tha, like, one day before the exam, instead of studying, we sit and think, what is life? How is life? What should we do in life? So we sit and do all these discussions morning 3 o'clock when you have exam at 8 o'clock in the morning. And then we decide, next exam na, itna achhe se padhai karenge, there'll be no problem. And after every exam, it is the same story anyways. 4 years ऐसा ही चला गया. So one of my friend is like, मुझे fame चाहिए. I don't care about anything else. I said, yeah, I just want money and time. I don't want fame. I don't want anyone to know who I am also. I prefer to be a hidden ninja type. I don't care about this fame. So it is fun. So, but that discussion helped me a lot. When I was choosing what I want to do, people still ask me, sir, you did IIT and why did you become a teacher? I said, yeah, what is the big deal? See, if my friend is working in Google, I'm as a teacher, right? If I'm earning as much as him or more than him, what is the problem? But अच्छा नहीं लगता है ना? You should say, hey, I'm working in Google, it feels good. So I said, yeah, I'm not interested. I don't care what people think, like where I'm working and all. So maybe it is because of the kind of background I came from. People didn't believe it. When I said I passed 10th standard, all the neighbors near it, they didn't believe that I passed 10th standard. Everyone was 100% sure I copied. that is the kind of expectations people had. When I said I got into IIT, people thought I got into ITI. You know what ITI? Diploma. And people used to be doubtful, I diploma करने के लिए चेन्नई क्यों जा रहे हो? I said, okay, yeah, let's not tell anyone what it is. Let them think that way only it is good. It is fun. When they came to know that it was more fun. Anyways, so frankly speaking, when I see you guys, that is one advantage that I see, the advantage I had and the advantage you don't have. No one had any expectations on me. Everyone was expecting I will fail. So there was no pressure only. Matlab, no one thought I was going to go into IIT. People used to laugh at my back like, "Tu IIT jaoge." I used to be really pissed off actually. So kind of, I used to use that negative energy a lot. Kind of worked out. Next thing, Pascal's law. So that is about the pressure and stuff. What is this Pascal's law? Simple definition, meaning it's a easy concept. The increase in pressure at a point is transmitted throughout the fluid and the walls of the container. What this means is, if you have a liquid and if you try to increase the pressure at one point, the pressure won't increase only there. It will actually get transferred everywhere. If you say this in the Mumbaikar language, right? If an extra person gets into a fully packed local train, not only the person near the door will feel the pressure, everyone in the compartment will feel pressure. Does it make sense? Right? So सबको क्या लगता है ना, this guy got into the door, so only that guy. Imagine, you have a bench here and only 3 people can sit. If a 4th guy comes and pushes here, what will happen? Everyone is going to feel the discomfort, right? It's not only the 3rd guy. Everyone in the bench will feel discomfort. So what Pascal's law says is simply that only. If you increase the pressure at one point, it just doesn't increase there. It will just get transferred everywhere. Right? Then, so let me give an example. Oops. The container is sealed. Let's say we have height h. This was point A and this was point B. So the pressure at A will be rho g h. If you take this height to be h by 2, the pressure will be rho g h by 2. Now in this container, if you just make a small hole, suddenly what happens? The pressure P naught is pushing here. The pressure here becomes P naught plus rho g h. At this point, the pressure becomes P naught plus rho g h by 2. So the pressure just bumps up everywhere by a factor of, by P naught everywhere. You're getting it? So there is a one pretty interesting video there. How do you make, spherical shells? I think I need to search that. Last time I downloaded, but I didn't have it. I'll show that later on. Clear? So the basic principle of this thing, now we use it in a hydraulic jack. Did you ever see this thing? Hydraulic pumps or something. Did you see this thing? When they break the roads, now they have this big hammer jack to drill the roads or something. They actually use pneumatic pressure. So uska concept kya hai na? I'll just draw a rough diagram here. It kind of looks like this. You have a drill like this. So this is a jack kind of thing here. So there is one opening here and there is one opening here. So here you generate an air cup pressure like this, and here you have a flap. If you close the flap this side, the air will enter here, right? And this will push this thing, it will push it backward. I didn't draw it properly. It will push it backward. If I shift the flap here, the air pressure will push it this way. So by switching the flap, left, right, this will go front and back. So this is called a pneumatic drill actually. This is the whole concept of it. Using air pressure, you can drill it. Next time you see BMC people, when they're going to destroy or break something, they'll take a van with them. Inside the van, best example, right? Dentist. Kabhi gaye dentist ke paas? She actually uses a pneumatic drill. Did you see? There is a pump kind of thing which is making sound. So the drills and everything she uses to, sharp, clean your teeth or whatever, all that's actually pneumatic drills. Pneumatic meaning air pressure ka drills. If you see now under the chair, there is a footrest actually. By pressing that, she can increase the pressure, decrease the pressure. So there is an air cylinder there which is actually generating pressure. The whole concept of that is Pascal's law. So when you increase the pressure at one point, that pressure is transmitted to the drill and the drill will exert that force. So your dentist has that whole setup is actually based on the hydraulic drill. Or you can even see this BMC ka, what is that? Kachra wala truck. Did you ever see that thing? They will lift the dustbin and they put it inside this thing. That is actually a pneumatic crane. If you observe that to the side, you'll observe there are pipes filled with fuel. So kind of hydraulic fuel. So the whole concept is that. So if you increase pressure at one point, that can be transmitted to the drill point. So based on that, we have this thing called an hydraulic jack. So what is this concept here? Let's say we have a piston here, we have a big piston here. Let's say area is A1, area is A2, and this whole stuff is filled with fluid. Now, if you apply a force here, F2, because of this, the pressure will increase by F2 by A2. And this pressure will get transmitted to here, delta P. And because of this, you'll get a force F1, where F1 will be delta P into area A1, which is F2 into A1 by A2. So this is actually a force multiplier. So the force on this thing is given by F2. Example, if you take A1 by A2 is 10, meaning you know what? For every 1 Newton, we can generate 10 Newtons of force. This is how they lift the cars and everything, in the workshop. So whenever they want to repair the car, right, you need to lift it. They use a hydraulic jack. By applying a less force, you can lift heavier forces. But what is the catch in this? The catch in this is, if you assume this thing goes down by X, and this thing goes down by X1, and this thing goes down by X2, the volume is conserved. So we have A1, X1 is equal to A2, X2. So the work done by the first force, F1, will be F1 into X1. The work done by the second force, F2, will be F2 into X2. And if you substitute the values here, you will observe work done by F1 is equal to work done by F2. Both are equal. So you're not gaining any energy. Energy is conserved. So what is the catch? What is work done? Force into displacement, right? If you want more force, you will get less displacement. So you're compensating display or sacrificing distance in order to get more force. So in this ratio, right, for 1 Newton, we generate 10 Newtons. For 1 meter of displacement, for 1 meter that A1 moves only 10 centimeter. Did you get the difference? So in a hydraulic jack, right, we can get more force, but the displacement will be sacrificed. So something or the other, you can't get both. Clear? So let me ask you a question on this. So you get pretty straightforward questions on this, Pascal's law. If you think about it, your body also, did you ever notice this? When you lift heavy weights, there is a pressure on your eyes. Did you ever notice that?
Yes,
When you're
sir.
lifting little heavy weights, your eyes, right, actually they feel like little bulging or something. They put a lot of pressure on your eyes.
Sir, when we sneeze also that time also.
Yeah. That is because, the pressure, if you increase the pressure at any point in your body, that will get transmitted to every point in the body there. And out of all the points, that eyes are the most sensitive. That's why you can feel that pressure on the eyes. So when I was in 9th standard, right, I told you, I guess, right, my first object was to join Indian Navy. IIT was backup option. So I had glasses. My eyesight is minus 5.5. So the Navy doctor clearly told me, like, I just went to meet him and asked him, sir, aisa hai, can I go for LASIK surgery and can it work out? So that was I thought that on LASIK surgery ho jayega, so I can get in. He said, no, yaar, if you do LASIK surgery, you'll be rejected completely. I said, why? Then he told me, see, if you're working in Navy or Air Force, right? If you're working in Air Force or Army, right, you're at a high altitude, the pressure is less. There's a chance your eyes might bulge out. And if you're in Navy or something, if you're a diver, if you're working in submarine, the pressure is so high, the eyes might, go inside. So this will affect your vision and you might not be able to work properly in that extreme conditions. So based on medical grounds, right, you'll be rejected. So he told me then, don't think about Navy, forget about it, find something else. That is how the dream got crushed. And then I didn't know what to do. I said, okay, fine, abhi kuch nahi kar sakte. Then 10th standard board exams got over and my principal called up for career counseling. I too went to play everywhere. I went there. People are all sitting. I was in the last bench as usual. I was fighting. I was throwing something on someone and I was beating someone. Most common thing. Kuch kaam hi nahi hai. Teacher is seriously saying something. 10th standard ho gaya na? Now no one can say anything also. Then he said something. His son ka name is Raghav, okay? Raghav wrote an exam last year and didn't qualify. We all just stopped. Are ye to topper hai school ka. Then he said, even I gave the exam, I didn't qualify. Then now he caught my attention actually. Principal failed an exam. This is interesting. I was listening to him. Then he said, there's an exam called IIT. So I gave the exam. It is very difficult and all. So I couldn't qualify. Everyone in the class started, it's very difficult. Humko karna hi nahi hai. You know what I was thinking? That means if I do this exam, I'm better than the principal. So chal IIT karte. That is how I came to the word IIT. We didn't have any awareness, right? 2003 ka baat tha. People had no clue what the hell is what. Then I said, chalo, we will do IIT. See na, 10th standard kid, what you want to do? You just want to show off, right? You want attention from everyone. That is the main purpose in life at that age. So I said, chal ab IIT karte. Why? Principal didn't qualify. But that is the only damn reason. I didn't even know bloody what happens in IIT. What is IIT? I didn't know. Then I went to all different institutes. My mom and dad are not educated, they didn't even pass 10th. I'm the first guy to pass 10th in the entire family. So no one knows anything about education. So I had to go to the institutes. I found out everything, and I joined some place. For 2 weeks, you know what I was thinking? I told this many times. After writing IIT exam, I'll get a job. That is what I was thinking. Then finally किसी ने बोला था, boss IIT exam के बाद वापस 4 साल पढ़ाई करना पड़ता है. I was depressed, shocked. Didn't expect this. This was bad. So that was after 2 weeks. Then someone came to the class, people who qualified in IIT that year, na? They came to the class to talk to us. So that guy started telling IIT में क्या होता है. Then he told me, IIT में you get a lot of holidays, Saturday, Sunday holiday, 1 month winter holidays in December, May, June, July, 3 months summer holidays. Now someone caught my attention. I said, yeah, this is worth trying. You know, your passion ignites again. And then he said something, IIT में there's a swimming pool also. I said, yeah, bloody swimming pool is there. I should definitely study for this. मतलब life में और क्या चाहिए? Swimming pool is there. So you see, right? I'm a very simple idiot actually. I really didn't know anything. But small things, I was so fascinated. So, you know, he talked for almost half an hour and they're about to go and they asked, anyone has any doubts? Then I rose my hand straight. He said, what is a doubt? Can I use the swimming pool every day? That was the doubt. He said, अरे IIT कैसा जाना है, क्या करना है, उसको पूछो ना कुछ doubts. I said, यार वो सब I will figure out. तो उसका tension मत लो. If I go to IIT, can I go to swimming pool every day? He was laughing. He said, "Ha, you can go every day. It is allowed." I said, "Acha, good, done." So there, that is how my preparation for IIT, serious preparation started. I said, I got a goal in my life now. Holidays, holidays, holidays. That's it. Every time I used to feel sleepy at 12 o'clock after studying 5 hours, I used to think of, I have to study 1 more hour. Holidays, holidays, study mode. And the best part, Arushi was asking me to go to swimming pool. Kabhi gaya nahi maine. That is the best part. After joining IIT, I used to see the swimming pool. Abhi next month I'll join. Next month I'll join. That next month never came. I still don't know how to swim. I didn't join. I don't know why. I still don't understand why I didn't join. Maybe I was too distracted with so many other things. Na swimming pool maza nahi aaya. So I'm not sure though. But seriously, yeah, the holidays, IIT में इतना holidays मिलेगा, that was the main motivation for me to study. But it's I'm telling you, right, beautiful place. Any college, IITs, BITS or NITs, these are beautiful places. You know, you meet very good people, you have very good facilities and environment. Ready, you join these local colleges, right? It's a mess actually. I have seen. They're not exposed to anything. They don't have proper facilities and anything. Anyways, let's get back to this. So yeah, when I still think about it, I think that only I used to be so dumb. Seriously, I used to be so dumb. But if you notice something, right? I was wild, I was dumb, but I was adamant, committed. मतलब ये करना है तो करना है. See, even the reason looks very simple. But for a kid who is 16, 17 years old, that's a very big reason in life. Holidays. Bus 160 days out of 365 days college. 205 days holidays, right? First, that is in a year. And trust me, when I say holidays, I really played like mad. There are days when I used to play for 14 hours in a day. 14 hours I used to play in a day, holidays. Every Friday, class used to get over at 2 p.m. I used to come to the room straight, 2:30 to 5:30 computer games. 5:30 used to go to play volleyball. Play for half an hour, then kick the volleyball outside. They used to throw me out of the game. Then used to go play for football. They used to make me the goalkeeper. I used to throw stones on everyone. Then I used to go and play some other game. If they still kick me out from there, I used to go to the second floor and throw water on everyone. So people used to be scared of me. They used to take me into the team because they know if they don't take me into the team, I'm going to mess up the whole game. So I was pretty popular that way. 7:30 the physical activity. See, full physical activity. Either people are chasing me to beat me or I am chasing someone to beat. Kuch to hota tha, is running around in the hostel like mad people. 7:30 ho gaya, take bath and everything, then go for dinner. 8 o'clock, 3,000 people going for dinner at the same time. Imagine. Big mess. And dinner is from 7 to 9. 8 to 9, 9:30 तक dinner हो गया. We used to come आराम से talking, playing and everything. Fun place. Then 9:30, 10 o'clock back to the room. 9:30 to 1 o'clock computer games. I used to be a computer gamer. I used to play Counter-Strike and Age of Empires. So I used to be the team captain also. We used to win competitions. So it was a serious thing. 1 o'clock हो गया. अभी देखो ना, after doing this much hard work, don't you feel hungry? We used to go for the night restaurant, which is open till 2 o'clock. Go there and eat till 2:30, 2:30. Abhi 2:30 you come back to the room. Now after 2:30 you'll be so tired, right? So maybe a movie dekhte. So we watch a movie till 5:30 or something. After movie gets over 5:30, right? You feel like eating or drinking some tea or something, right? So outside the IIT morning, see, so IIT में restaurants कैसा है ना? Morning first restaurant opens at 6. The last restaurant closes at 2 o'clock in the night. So 2 to 6, this 4 hours you won't get food. So then 5:30 we used to go for a walk, have some chai, come back, and then around 7:30 we used to remember breakfast is the most important meal of the day. True, right? So then we used to go and used to have breakfast. Then 8 o'clock aa gaya. Abhi now, if you see the morning 7:30 is the time when the entire things actually quiet down a lot. People are sleeping now. So 8 o'clock I used to sleep. And then around 12:30 को someone used to come. Arun, wake up! Arun, wake up! I said, अरे क्या हो गया? Get lost करके. अरे बिरयानी खत्म हो रहा है. Shit, बिरयानी खत्म हो रहा है. Let's go. So because 12 to 2 is the mess ka time, right? If you don't go early, biryani खत्म हो जाएगा. Quite important in life. So 12:30 you get up and start running for biryani there. And then we go finish our biryani. You come back by 1:30, 2 o'clock. 2 to 5 games. Start playing computer games again. Then evening 5 o'clock, most of the time I used to go to play some sports or something. But sometimes you're sleepy because I didn't sleep enough now. I used to take a nap for an hour or something, then used to get up and again start going and playing everywhere. Night dinner, night game, same story on Sunday morning, again sleep at 8 o'clock. Afternoon 2 o'clock, na, you start realizing something in life. Sunday afternoon 2 o'clock. Kuch to gadbad hai. Then you realize bloody Monday morning there's an assignment submission. And kuch nahi kiya. Then afternoon 2 o'clock you start calling everyone. Are wo assignment complete hua kya? Assignment hua kya? Nere evening na 6 o'clock we will sit na together we will do. I said good. 6 o'clock sab karenge. Tabhi kya karenge? Let's go back to gaming. Evening 5:30, 6 o'clock you call him. Are kya hua? नहीं रे वो क्या है ना अभी नहीं डिनर खत्म कर लेंगे ना then we will sit. I said that's a pretty brilliant idea. Okay, that's a brilliant idea. Let's sit after dinner. We can focus much better. Then you call him at 9:30. अरे क्या कर रहा है? छोड़ ना यार क्या करेंगे ऐसे कुछ नहीं हो रहा है. Let it go to hell. All these assignments and all we won't use it in real life. Nothing applications. Like we are just wasting our life करके. I said ये भी सही है. That also looks right. That is one guy. Another guy, you ask him, he's like, मेरा assignment खत्म हो गया. I'm sleeping. Don't wake me up. So you will find all kinds of people. So now you're scrambling, running around 11, 10:30. You'll find someone who did the assignment. उसके पास जाके you either copy it or you learn. जो भी है, you finish it off. Now 12:30 in the night, Sunday night, you're sitting on the bed and waiting to sleep. You tell me, the guy who sleeps 8 in the morning, 12:30 को नींद कहाँ से आएगा? You're sitting there and staring at the walls. You're telling yourself, Arun, sleep, because morning 8 o'clock class important. Monday morning 8 o'clock class is the most bunked class. And if you have less than 15% attendance, you fail the course. So people have a list, okay, how many classes you can bunk on Monday morning. So when the course starts, first thing we do is we make a list. Kitna classes bunk kar sakte hain. And if you're already close to the border, you don't have an option. After struggling and doing everything, you sleep around 3 or 4 o'clock. And then you wake up, again the cycle starts. Monday, Tuesday, Wednesday. Then Monday morning, you tell to yourself, Naina, I'll sleep early karke. So Monday night, you try to sleep early, you sleep by 2 p.m. Wednesday night, you sleep by around 1 o'clock. Thursday तक schedule proper हो गया 12:30. Friday again start 8 o'clock. Rinse and repeat. This It used to be fun, right? Did you guys ever play morning 3 o'clock rugby? When it is raining, middle of the hostel floodlights. We used to have two teams, one team with bunions, one team without bunions. People are playing rugby, hitting each other, fighting, everything. By chance, someone fractures a leg. Everyone is sad. You call up the ambulance, comes in 5 minutes and takes you. We have an hospital inside. Oh, kuch problem nahi hai, but everyone is sad because you don't have extra player now. Then they come running to you. Arun, get away. Sir, kya ho raha hai? Sudhir ka leg break ho gaya. You open the door. Huh, what happened? Nothing. वो चला गया. तो गेम के लिए एक और player चाहिए. That is how idiots are. So yeah, it works. Put some effort. It is worth it. Trust me when I say that. It is really worth it. I still remember after 12 years I have been passed out. देख कितना खुशी है. I'm really happy. Like, I feel very happy remembering all that stuff. The kind of idiots I met there. I told you, the first year someone got lost in the library. This guy was dancing in front of camera. He was calling everyone in the camera. No one is responding. Once he started dancing, the librarian came and threw him out. He said, "Thank you, sir." Librarian asked, "What happened?" "I got lost. I'm searching for half an hour. I couldn't find the way out." So if I call for help, no one is responding. If I dance, so you thought I'm doing some mischievous thing and you threw me out. Sir, yeah, people do think creatively, right? Let's get this thing. Let's finish it off. So which point has more pressure? Arrange PA, PB, PC. Arrange at pressure A, pressure at B, and PC. Which is a greater? So we have first one, there are 4 pistons. Second, 2, and third is 1. Done. What is the answer? PA, BCA. See, listen, I'll tell you one thing. Do you remember this question? If I have a fixed year, if I apply force F, or if I apply 2 forces, which has more tension?
Sir, it is same only.
Same, na? Because sabko kya लगता है, right? They think there's only 1 force, there are 2 forces. You're forgetting wall is also pulling, right? The tension
Yes,
is same. So tell me one thing in this scenario. If you don't have this force on this piston, what would have happened? This piston would have gone outside, right? That means this force F is playing the wall of the roll, isn't it? If you draw the FBD of the liquid, what do you see? If you just draw FBD of the liquid, you'll observe, take any liquid, okay? This is the force due to the wall. This is the force. This is the force, and this is the force due to the wall. Are you getting this? So what will be there then? So if you take any one point here, so how to find pressure anytime? Take a piston. This is force. This will be pressure into area. So pressure is F by area. Does it matter how many forces are applied? Therefore, PA is equal to PB is equal to PC. So it's an illusion, you are getting confused thinking there's only one force. Isn't the wall is also exerting force? Are you getting a point? The wall is also exerting a force which is same as this force. You are just not seeing it. Is this clear, everyone? This is a good question. This was a mains question. Just people think this thing. There are 4 forces, the pressure should be more. Check it out. This thing.
Recently, some friends of mine went to the Gordon Dam.
There. Can you see the Damka wall? This is what I was saying. It is bent like an arc shape. So when the liquid is pushing now, did you see how it is? Where is the water? Water is on the right hand side. So when that thing gets filled up, right, the water is pushing it. It's actually being pushed into the mountains. So that actually becomes pretty strong.
Dam in
This is actually a
Tasmania,
different concept,
which is
though.
126.5 meters, or
Quite tall, no? That's one. Where is that? Where is that? How do you make spears?
I've come across a small video clip in various compilations on YouTube.
So what they do now, this is how they make spears actually. You want to make a full round spear. Can you see on the top, there's a bomb there. There's an explosive. So when it explodes, what will happen? It will push the water down, right? So the pressure will get transmitted everywhere. So if you push something equally in all directions, it will form what kind
Found
of
a
shape?
small explosion going off inside of a polygon-shaped sphere, which forced it into a round sphere.
Did you see what happened? You got a spear. So when it blasts, right, the pressure will push the liquid inside and the liquid will push that polygon in all directions equally. It becomes a spear.
The video usually only lasts a few seconds, so I didn't know what the objects were or what was happening, but I really wanted to know. So I started doing some research and found a company in China who makes stainless steel spheres for
So they make spears like this. Then they polish it on the outside, becomes shiny.
sculptures. The company's
And the best thing, you know what? These are very perfect spears. You can't make them. If you try to make with a machine also, right, there'll be some deformity. But this thing will generate an equal pressure. You always get a proper spear.
name is Shenzhen Maoping Sculpture Arts. They have been making stainless steel spheres for 23 years and can
So first you have to make a polygon and then weld it and then you blast it. Okay? So that was one. Okay, so
So
that is
blast
about.
it as in what do they do?
What they do now, they fill up the entire thing with liquid and they put an explosion on the top and then they blast it.
Oh, like sodium.
No, not so. No, they keep a small explosion, like they put a small dynamite.
Oh, okay.
So when the dynamite explodes, what will happen? It will push the air outside and the water inside, na? So when you push the water inside, suddenly there's an increase in pressure. That will get transmitted to the walls and the walls will expand. It becomes a spear. Okay. So that is one. So yeah, we'll wrap up with this thing for today. So tomorrow we'll catch up.
Why they don't put the bomb at the center of mass of that polygon?
Array, then the water will come out na re. Okay. So today I won't be able to take doubts, right? Tomorrow, any doubts that you have, I'll take up tomorrow. Anyway, tomorrow also a meeting. Na? Tomorrow let's catch up at 9 o'clock, 9 to 10:30. And then we can sit for any doubts that you have. Right? So we'll see tomorrow. We'll continue from here. So make sure to revise, especially the projected area and all that stuff. And I hope everyone started doing SSM. And the exam deadline is that. Did everyone give the exam? I'll just extend it till Sunday night, 12 o'clock. Give it. Rishi, I wrote it before. Didn't write it, na? So Sunday tak click learn. You have time. I know tomorrow you have a class till 10:30. You won't have time. So I'll extend it by one more day. So do give it. Okay. Chalo, I'll see you guys tomorrow then. Take care. Stay safe. Any doubts in today's class, you can ask me. But if you have any other doubts of your own, let's see tomorrow.